Welcome to our NPTEL courses on power quality improvement technique. We shall discuss on the control technique of UPQC. In our previous lectures, we talked about that mainly the Q UPQC Q, and now its rating and its SAC control, and we shall continue from that discussions only. So, the rating calculations of the DVR and the DStatCom can be done from the phasor diagram, which we have shown from the previous figure, that is the quadrature and all those things. Please refer back to my previous lectures to correlate. So, the injected voltage of the DVR is given by under root of, this is a voltage after compensation and this is a voltage before compensation. So, DVR voltage is under root of VLC square minus V square. The rating of the DVR is essentially then S DVR, that is the kilowatt rating. So, voltage rating and the current through it, which is flowing through it, because it is a series connection. So, current will be the same. So, ultimately this will be given by Vs IL cos phi into tan delta, where delta is the new angle between the voltage and current after compensation, where Is and IL are the supply and the load currents respectively, and cos phi is the load power factor, delta is the angle between the load voltage and the voltage after compensation. So, ultimately this will be the case. So, this will be the rating. You try to minimize tan delta, so that the rating of the DVR will come down. Now, let us talk about the current that is being injected by the shunt part of the devices. So, that is the, let us assume, as in a previous case also, the load current is IL. So, you have these expressions, that is the, we have mentioned in our previous case that x is the sag factor. So, it will be IL into 1 minus x square plus cos phi square minus 2 cos phi minus eta 1 minus x by a. So, there are few new terms and it will be delta. So, the VA rating of the DStatCom is essentially, it is your the VLC, the compensated load voltage into the IDST. So, therefore, the total VA rating of the UPQC will be summation of this SDVR and the SDST. So, both this has to be add up, this will be the total kilovolt or the megawatt ampere level of this UPQC. So, thus what we can say, for the control of the DStatCom part of the UPQC, the sensing of UPQC, voltage, load current, supply current and the deceiver's voltage required to be derived from the reference current of the PWM control by SRF or instantaneous reactive power theory or other technique which has already been mentioned. So, all whatever may be this method, you can incorporate it. The supply current have to supply the active power, which has two part. One part is a load active power, another part is that of course, there are all those elements are non-ideal, inductor, capacitor, it carries series resistances. So, to meet the losses and the switching and the conductance losses of the switches of the UPQC, all those will be lumped, and so it will be load active power plus those losses, it will be taking from the source. The active power component of the load current is estimated by SRF or instantaneous reactive power theory. We shall discuss in detail SRF transformations of the load current and then filtered for its DC component, which are present the required active power component of the load current. For SRF transformation, the transformation angle is obtained from the PLL. This is very important entity. The PLL is a very important entity. We require to talk about PLL in detail. That will be done hopefully in next class. So, the phase lock loop for the positive sequence PCC voltage. The other part of this, the other part of the active power component of the supply current is estimated using the PI controller, which I have shown in my previous class, controller over the DC bus of the UPQC. That is a indirect method. You can also have a direct method. The sum of this active power component of the active power component of supply current is considered as the amplitude of the reference currents. That is something we require to take into consideration, the sum of this active power components. So, this is losses, there is a load current, and to maintain the DC bus voltage little higher than the rectified voltage, you require to get some amount of extra voltage, extra power. So, all those require to be fed from the source. So, for this reason, the sum of this active power component of supply current is considered as the amplitude of the reference supply current. So, you have, if you have, so you have IL, that will have IP of t plus IQ of t plus summation of IH n equal to 1 to infinity. So, IP part should come from the source plus I loss, because there will be some amount of the energy that will be loss, that will accommodate the loss for the switching, and there will be some part to maintain the DC bus voltage, that is ISD, and thereafter that is comes from the PI controller generally to maintain the DC bus voltage. So, IP of t plus I loss of t plus ISD, this all will be the in phase component of the current, and that required to be fed from the source. So, the amplitude of this reference supply current and the transformation angle obtained from the PLL positive sequence PCC voltage are used to compute the 3 phase instantaneous reference supply current. So, that is something we will see in our next classes, how PLL function and how we generate this reference in this method. So, these are the 3 reference supply current. Generally, if you have a 3 phase 3 verse system, 2 reference current is sufficient, and you can get another current by subtraction from 0, and sense the supply current used in a PWM current controller for generating the getting signals for the IGBT and the DStatCom. So, what happened? Let us go back, how does it work? So, you have IL minus IP star, and this is letter IP star. So, ultimately you got IF of t. So, this you have this reference current, and So, generally it is been compared in a ABC what actually you are injecting, and that you feed it to the PI controller, then you have a PWM block and that have a switch. So, for the one leg. Similarly, we have a 3 such pulses. So, generally it is a unipolar in nature for the 2 level inverter, and accordingly to the multi level inverter we have a multi level switching scheme. So, for the for the control of the DVR, reference current is injected. For the next, now let us talk about this. For the control of the DVR, the reference injected voltage are computed from the reference of the load voltage and the source voltage as PCC. So, we require a voltage sensors, we require to check if there is a sag or swell, and accordingly voltage will be injected or voltage will be taken out in case of the swell. The 3 phase reference load voltage are computed from a desire or the reference amplitude of the load voltage, and the transformation is obtained from PLL over sense DVR on the supply current. The 3 phase reference injected voltage are given to the PWM voltage controller for generating the grating signal for the IGBT or the DVR. Now, this is the case for the UPQC-Q. Now, let us talk about the UPQC-P, where the voltage is injected in phase. So, DVR voltage is injected in a phase. So, ultimately you do not have much change in the phase angle, that will be remaining phi. So, it was phi because previously we had a 2 angle, because before, after compensation the voltage between the uncompensated voltage and the compensated voltage become this angle in between in case of the Q, but that angle is not possible because you are injecting a voltage in phase with the current. So, what happen here? So, your phase will be same, but what happen, you got a extra current, IS was flowing, instead of that IS prime will be flowing, and ultimately difference was this DVR voltage, that is the previously it was Vs, now it is Vs prime, and VL should be the load voltage that is required to be constant, because we require to keep the sensitive load at a constant voltage. Now, this is the control of the UPQC-P. This algorithm UPQC has been conceptualizing for the minimum voltage injection, because once you inject in a voltage in phase, so maximum force injection will take place. So, of course, you got a VA and you get VB, resultant is VA plus VB when you inject it in phase, and that is the maximum you can achieve. As an evident from the phasor diagram, the DVR injects the minimum voltage. Thus, rating of these devices required to be low, that is one of the major advantage of it. For both conditions of the sags and swell, and moreover generally this UPQC-Q does not have a capability to mitigate swell. Here, since it can mitigate swell by injecting a out of phase, so that swell can be mitigated. In this mode, DVR need the, but problem lies it has to handle the reactive power, not only losses, but also this sag. If you are mitigating sag, that extra power will come from the shunt path and ultimately inject the voltage, and reverse, when there is a high voltage, then it should take out this voltage and ultimately try to flow from the shunt path. If it is not possible, then it has to be bleed out by the bleeder resistances. In this case, the series voltage is injected in phase with the AC mains current or the PCC voltage, thus requiring only the reactive power that has to be fed or received by the D STATCOM through the DC bus. So, in this it increases the current, since the current has to be increased because real current in phase will flow, and thus the KVA rating of the D STATCOM will be higher. However, KVA rating of DVR will be minimal because of the less voltage rating. Voltage rating required to be very low, and its operating mode is called as UPQC-P. So, ultimately it passes the buck on the shunt path. In this case also the D STATCOM compensate the reactive power of the consumer load. So, rating of this, because if in case of the sag, so that extra voltage should come from the shunt path. So, DVR will compensate the sag fine, but that extra current has to flow from the shunt path. The rating of the devices of the shunt path required to be increased. And the consumer, so what happened, the active power of the consumer load and current related to the harmonic problem. The voltage sag can also be expressed as X equal to VLC minus Vs by VLC equal to, ultimately we know that this difference is injected by the DVR. So, that will be DVR by LC. Therefore, the voltage rating of the compensator may be achieved from the required minimum value of the sag and the swell compensation. Now, in case of the UPQC-P, as we have mentioned already that mode of operation requires minimum injection of the voltage and thus minimum VA rating of the DVR, but at the expense of the D STATCOM current rating, which increases due to the large active power flow from D STATCOM to this DVR. Therefore, this type of UPQC does not have minimum overall rating. It may be the DVR rating is low, but D STATCOM rating is high. So, it is not optimized and consisting of the both the element of the UPQC. The rating calculation of the both DVR and the D STATCOM, we can do that as we have done in case of the UPQC Q. The injected voltage of the DVR is, so it is VLC minus Vs, ultimately we can refer it as a sag factor VLC into X, that is X is a sag factor. So, similarly the rating of the DVR and in total can be expressed as DVR equal to DVR into Is equal to LC into I cos phi, where Is and IL, Is is a source current and IL is the load current respectively, and the cos phi is the power factor of the load current. So, current rating of the D STATCOM will be IL square minus Is square. So, that is the extra current has to flow plus XL cos phi square, and from there that the VA rating of the D STATCOM will be LC into I DST, and the total rating as we have seen, it is DVR plus D STATCOM. So, what happened here, for the real control, the implementation of this mode of the UPQC is also little straightforward, because you straight away try to compensate in phase component. Similarly to the D STATCOM, control from the UPQC mode of operation. So, thus what happened, for the control of the DVR, the reference injected voltage are computed from the difference of the reference load voltage and the sense PCC voltage. So, what happened you have you know that what should be the reference PCC voltage and what actual voltage at PCC you might be calculating from your PCC voltage from your voltage sensors. So, that voltage generally we always put a PI controller. Why? Because PI is a history, proportional, because you are ultimately you are switching by PWM, thus you require a proportionality constant, because your sine triangle ratio is such that we require a proportionality constant, and to eliminate the steady state error we require to put the PI controller. Ultimately you got some value, sinusoidal value. This has to be have a sine triangle PWM, and from there you get the getting pulses from this your DVR to compensate the sag. So, this is a way of operations for your way of operation for your DVR part. So, that is all it is. The control of the DVR reference is injected, voltage is computed from the reference between the load voltage and the sensed PCC voltage. The 3 phase reference load voltage are computed from the desired or the difference amplitude of the load voltage, and the transformation angle is obtained from the PLL. That is something we require to see how does it PLL works in case of the dirty environment when voltage is not cleaned. For PLL, over the sense PCC voltage at this 3 phase reference voltage are to be in phase with the PCC voltage. So, you require to inject the voltage, what is there, it is this. So, that is been done with the help of the phase lock loop. The 3 phase reference injected voltage are given to the PWM voltage controller to control the voltage. So, what happened, if you go back, I require to little modify. So, ultimately this generally converted, all are converted ABC to DQ. So, from theta, this theta comes from the PLL. So, your actual PCC voltage is available. So, this is the PCC voltage A, B, C, and ultimately you got D and Q. Generally Q does not count. So, you got some value of this voltage and this is your VDC reference. So, you got a PI because PI works better in DC. Now, again you reconvert into DQ to ABC, and same theta is applied and theta is generated from theta or phi, whatever may be, is generated, so that it ensures that you inject the voltage in phase at the PCC. So, that is what it has been written here. This 3 phase reference injected voltage are given to the PWM voltage of the controller. Now, this is the phasor representations of it, but this is for the S type, where you try to optimize overall KVA rating of the UPQC. It is generally what happen in case of the Q, your D StatCom rating is low, but power rating of the DVR is high. But in case of the P, your DVR rating is low, but D StatCom rating is high, but here you try to optimize the overall KVA rating of the UPQC. So, this is the purpose. So, let us discuss what has been written in this slide, thereafter we shall discuss the phasor. We have already discussed this, because if you want to have a sag compensation, instead of compensating at this angle in phase in case of the P or in case of the quadrature, you can inject the optimal angle by choosing the effective utilizations of the DVR and your D STATCOM rating. So, both will be optimally loaded. It is not that very high amount of the current will flow to the D STATCOM as in case of the P, or very low amount of current will flow in case of the Q, but your DVR rating is high. So, accordingly you will choose this injection angle, and thereafter initially you had a current, that is IL, and you will inject this current to make it a, and there is a angle between IS and IL, that angle was phi. Ultimately you will inject the DST, so that will make this component in phase with the supply voltage. Similarly, in case of the swell, it can also compensate the swell, and ultimately you can see that this is inject like this. So, you get a proper utilization of both the entities DVR as well as the D STATCOM. So, thus what we can say here, this control approach of this power quality conditioner has been featured as a most generalized one. Full utilization of the DVR rating with reduced burden on the D STATCOM or optimum sharing rating between DVR and the D STATCOM, it has been featured into this UPQC S based system. From the phasor diagram of the DVR, as I explained little earlier, the DVR may inject the voltage in the both condition, voltage sag as well as the voltage swell compensation. The UPQC S mode of operation, the D STATCOM, is normally used for all current based compensation other than received the full power system compensation. So, this is the way it will work, and thus what happened in this configuration. In this case, the DVR injects the voltage in series, the AC mains and the load end of the predetermined phase voltage, and that will be optimally compensating the rating with respect to the PCC, not that in phase or not that in quadrature. It is some optimal angle that required to be calculated. It needs both active and the reactive power through the DVR. The concept of UPQC S with the phase angle with the series voltage injection of the DVR has been perceived very recently for different objectives. So, let us see that what is the objective. So, first objective is to utilize the proper rating of these devices. So, first objective is to mode of control of UPQC is based on full utilization of the DVR rating. So, DVR rating has to be fully utilized, then only you load the current handling capability of this D STATCOM. Usually VSC of the same VA rating used for DVR and the D STATCOM to reduce the inventory for the manufacturing, and also if you have a different voltage rating for the different switches, so your inventory cost will increase. So, we try to maintain the same voltage level for DVR as well as the STATCOM. So, for this reason, first you load the DVR fullest and then the current rating will follow. So, thus you can have a total optimization, or you may have a different optimization, you may refer to the paper. So, that rating can be optimized by any soft computing technique also, it has been reported. So, reduce the inventory by manufacturers and the customers are identical voltage source converter are selected for both the component of the UPQC. In general, the DVR is used with an injection transformer. So, to get rid of the high frequency noises which we have seen in our, or the high frequency switching ripple which we have seen in our previous lecture. But a transformer is not mandatory in case of the D-STATCOM unless a customer need it or the grid court forcefully enforce it. So, for this reason the control of this UPQC method may be as follows. The voltage injected by the DVR is the rated voltage, that is DVR equal to R, and this angle psi DVR at which to be injected with respect to the PCC voltage. So, psi is equal to, we can calculate psi, that is the one of the challenge online, pi minus cos inverse of Vs. So, that is the source voltage, that is a rating of the DVR, and that is a compensated PCC voltage by 2 Vs into DVR. From there we can optimally calculate the value of psi. So, why it is optimal, this value of this Vs may be changing due to sag and swell, accordingly the injection angle required to be changed. So, where Vs is the PCC voltage under sag condition, Lc is the load voltage after compensation. So, in that way we require to calculate and inject this voltage psi and compensate this voltage. So, in this way this will continue. Now, the reactive power of the DVR is P DVR equal to DVR into Is cos phi cos psi DVR. Similarly, it is sin psi DVR, and let us explain the phasor diagram. So, here you will apply this angle optimally. So, this was 90 degree and this is a applying voltage. Similarly, you had this value of Is and you can apply this shunt compensation Is psi, and that will, and it may be at a different psi, and thus you get a psi prime, and you may get this injection and you get psi prime again. So, what is phasor says that from this angle you can have a different value of psi compensation. So, you can play around with psi and magnitude of the compensation current. This condition of the DVR is considered for the compensation by DVR with minimum active power and maximum reactive power with full utilizations of the DVR rating, that is DVR equal to DVR R, and this VR rating of the DVR is S into DVR into I, and thus it follows like this. So, from there what we can say is that the current rating of the D-STATCOM equal to Is sin beta square plus IL cos beta minus cos phi by 1 minus x, x is the amount of the sag, and the VR rating of the D-STATCOM is definitely is equal to Vs into I DST. So, total rating will be definitely is DVR plus IDST, and this computation what happened in UPQCS reduces the burden of the D-STATCOM rating as some portion of the reactive power of the load is supplied by active power of the load is also supplied by the DVR. So, thank you for your attention. We have discussed about the control technique of the S type UPQC that has been featured and been used for superiority over for its on UPQC-P as well as Q. In next class we shall discuss about this grid connected voltage source converter and the PLL. These are the two entities which has been frequently used. Mostly today we are concentrating on the compensation of the DVR, and we will also see that how the STATCOM also employed, and we shall discuss about at least two technique, important technique is SRF method and the instantaneous reactive power flow. Thank you for your attention.